I'm going to show you how to use your Raspberry Pi to mine Ethereum on the blockchain. I'm also going to reveal exactly how much cash I earned mining for 24 hours. And yes, it is possible to earn Ethereum with no money down by simply running software on your Raspberry Pi. But will this be lucrative? Really, that depends on where you think the price of Ethereum is going to go in the future. And just as a personal anecdote, back in 2013, I purchased 0.25 BTC, or a quarter of a Bitcoin, for just $271. And at the height of the market back in November, that was worth a little over $16,000. Similarly, back in 2017, I purchased half of an Ethereum for a little over $250, and at the height of the market, that was worth $2,500. My only point with this is that this hypergrowth has happened to people even within recent years. Next, the window of opportunity around mining Ethereum is rapidly closing. That's because at some point in 2022, Ethereum will be migrating to a proof of stake model that will greatly decrease the need for miners and also introduce barriers for the layperson to contribute. And after that transition is made, miners are going to have to stake 32 Ether just to become validators, and that's over 100 grand. And just to set the stage a little, Ethereum is a DeFi system that Vitalik Buterin minted into existence when he had the breakthrough realization that the blockchain could store executable programs, aka code. This realization led him to creating a programming runtime called Solidity that could be compiled, stored, and executed on the blockchain. And this discovery gave way to new and novel concepts like smart contracts, decentralized autonomous organizations, or DAOs, and yes, you guessed it, NFTs. Personally, I think Ethereum is a solution in search of a problem, similar to how Bitcoin's initial white paper presented the concept as a currency, but then later settled on a store of value or digital gold. Ethereum can't quite claim that it's a good cryptocurrency because it's slow and cost prohibitive, but I do think Ethereum will find its killer app at some point in the near future. So I do want to be transparent that in 2022, there are probably more lucrative uses of your Raspberry Pi, such as maybe creating a DVPN node on a network like Mysterium, or sharing your SSD storage on a decentralized storage system like SCPrime. Instead, the value of this process is probably not the Ether you'll be able to accumulate, but rather the knowledge asset that you'll be able to gain by going through this exercise. By building out your Ethereum node, you'll be forced to acclimate yourself with the prevailing tools and deepen your understanding of how crypto works at a fundamental level. And it's that knowledge that will be used in turn to create new work opportunities in the future and also help you make more sound investment decisions. So real quick, unlike Ethereum, there is no gas limit on expressing your gratitude. So go ahead and hit that like button and help us get this message out to a wider audience and evangelize the good word of crypto. So with that being said, let's get hashing while the hashing is good. Okay, so these are the items that we're going to need. I'm using a 4 gigabyte Raspberry Pi 4. We're gonna need a solid state external hard drive. We're going to want to use Ethernet for our internet connection. And then we're going to need a micro SD to SD converter so that we can flash the operating system for our Raspberry Pi. So I just popped out the SD card and I'm gonna slide it into here. Okay, so now we can see our boot drive showing up here, so that looks good. And we're gonna flash the operating system using Raspberry Pi OS. If you don't already have that installed, you can just go to raspberrypi.com and go to software, and you should be able to install that. Okay, so for operating system, we're gonna go to Raspberry Pi OS Other, and we're gonna select the full 64-bit operating system. And then we're gonna select our 32 gigabyte micro SD card. Be careful not to select the wrong drive there because you will overwrite everything. We're also gonna wanna pre-configure a couple things. So we're gonna pull up an advanced menu using Control-Shift-X. So we're gonna enable SSH and provide the Wi-Fi credentials for our router. I'm gonna go ahead and click Save, and then we're gonna select Write. Okay, so now we can go ahead and remove our micro SD card. Okay, and now I'm just gonna throw it into the Raspberry Pi. All right, so I just plugged in the Raspberry Pi to the power source. Also going to plug in the Ethernet cable. Boot it up. Okay, so now that the Raspberry Pi is plugged in and turned on, it should be discoverable from any other device on the same network. So on my laptop here, I should be able to ping the default host name, which is raspberrypi.local. And I should get responses to that, and I am. So that looks good. So the next step would be to SSH directly into the device. So I'm going to do SSH pi at raspberrypi.local. This message just means I need to clear out some of the stored fingerprints. So there's a file called known hosts, and I'm just going to remove the old entries and save that file, and then it should work. I'm going to say yes, and then it's asking for the password. The default password is going to be raspberry, and we are in our Raspberry Pi device. So this looks good. Now we can also do the same thing from VNC, which is a remote desktop client. So if we wanted to do that, we could come over to a new window, and just to enable remote desktop, I'm going to elevate myself to root, and then I'll do raspi-config, and then we can do interface options, VNC. Let's enable it. It's now enabled. Finish. So now we should be able to connect, and there it is. Okay, and now we have a GUI, graphical user interface, for the same Raspberry Pi device. Some people find this easier. I'm actually more fluent with the command line and prefer that, but just wanted to provide you with both options. Okay, so we're in a Raspberry Pi device. All right, we're just gonna update the package list by doing apt-get update. Okay, so now we want to download GETH, which is the Ethereum implementation written in Golang. So I'm going to go to Downloads, and there should be a section for Linux. Okay, so we're going to want ARM64. So I'm going to right-click this and do Copy Link Address, and we're going to just pull it directly to our Raspberry Pi using wget. Okay, and then we're just going to unzip that, and then we're just going to feed it the file name. And then we will step into the new directory that I just created, and we're going to change the ownership on the GETH file. And then we're going to copy the GETH file into user local bin. And then we're just going to validate that GETH is installed correctly by running geth version. And this looks good. So we're likely going to have to mount our external SSD drive. So the way we do that is by running this command here. This will tell us how our SSD drive is represented on the operating system, and then we can use that to mount the drive. And to mount a drive really means to just point it to a folder that's local, and it kind of creates like a symlink. So I got SDA, SDA1, dev. We're going to create that folder first. So we're going to do make dir Ethereum chain, and then we should be able to run this command here. So the drive is now mounted. So now what we want to do is run the miner pointing to the mounted drive. We're going to do GETH account new. And then we're going to create a password. Okay, and it's going to give us the public address of our Ethereum wallet. Okay, and to sync our node, we want to construct a command. So a couple things. We want to pass our new Ethereum wallet address into here, and then we want to make sure that it's referencing Ethereum chain. We're going to increase the cache to 3,000 megabytes and set the peers at 10. And then in another terminal here, we can just make sure that the mining is running by running htop, and it's going to show these miner scripts here. And then we can also run geth attach, which opens a JavaScript console, and then I have a script that will print out periodically our progress as far as syncing goes. Okay, and now we can see our ETA, our estimated time. So it takes a while to download the blocks, the states, and the try cache, there's a lot to it. And basically once the node is finished syncing, it will start mining. One other thing that we might want to look at is the actual folder where everything's stored. So if we go into Ethereum chain data and go into key store, we can go into GETH and we can see that the chain data are these levels.db files. So in the end, our Ethereum node did not yield us any profit, and that's because we were doing independent solo mining. So it was very unlikely, given our hash rate, that we would actually discover the newest block and receive the block reward, although that has happened before. Now, something that you could do is join a mining pool, but they would be unlikely to accept someone who only has a small CPU to contribute. Anyways, this is still a very good exercise for learning more about how crypto works and better understanding the decentralized ecosystem. If you get stuck or have issues setting up your node, please do not freak out. Yes, I'm looking at you, Jedi Knight. Instead, hit the link in the description below and set up some time. We can get on a call together and find a solution for you. Anyways, as always, go ahead and subscribe, and thank you for watching.